Around 2,300 years ago, there lived a man who would come to shape the course of history with his studies and teachings of our natural world. His name would come to be revered and showered with praise for his ideals and ventures in trying to define the many aspects of not only our Earth, but as well as the stars and planets above. His name was Aristotle, a Greek philosopher and scientist whose views and beliefs would become accepted as the truths of our world, even millenniums after his death. He supported the thought of the existence of four basic elements that comprised our planet. These were earth, water, air, and fire. He also proposed the existence of a fifth element, ether, but unbeknownst to the Church. His beliefs are collectively known as Aristotelian natural philosophy, and combined with Christian theology, scholasticism, they become the dominant perspective on the workings of the universe. There would come men of inquisitive natures, as well as the means to satisfy their questions, those of which would unravel the truths of the natural phenomena occurring through the use of empirical study and concrete evidence as opposed to the idealistic way of explanation that was found in Aristotelian natural philosophy. In the 1500s, there was a man who had come to be amongst the first of many challengers to the prominent Aristotelian natural philosophy at the time, and his name was Nicolaus Copernicus. Nicolaus Copernicus was a Polish astronomer who proposed a model for the solar system known as the heliocentrism. Through observation of the stars and planets, as well as the use of mathematical formulas, he came up with the idea that the sun was at the center of the universe, as opposed to the popular notion at the time that the earth was at the center. In 1514, Copernicus made available to his friends a 40-page manuscript entitled Commentariolis. It outlined the basic principles, understanding, and axioms of heliocentrism, and caused him to gain a fair amount of controversy. Decades after Commentariolis, as Copernicus was on his deathbed, in 1543, he finally published his book, De Revolutionibus Orbium Celestium, or in English, On the Revolutions of the Heavenly Spheres. This book explained in full detail his heliocentric model of the solar system, and strived to make others suppose the possibility of the sun, rather than the earth, being at the center of the universe. It was largely met with criticism and disdain, especially from the Church, which is due in large reason to the model's opposition to the Church's teachings. It was eventually banned by the same entity, and this ban was not lifted until somewhere around the 17th century. Yet progress did not stall for long, as another scientist, who starved for answers as his predecessor, began to make leaps in astronomy through the use of mathematics and observation of the stars and planets above, not to mention the foundation supplied by Copernicus himself, the heliocentric model. His name was Johannes Kepler. Kepler was a German mathematician, astronomer, and astrologer. He, through the use of comprehensive and accurate empirical data gathered by his employer Tycho Brahe and mathematical computations, formulated what is known as Kepler's laws of planetary motion. Kepler's law described in detail the course and orbits of planets in the solar system, including how to calculate within a reasonable margin of error. He also described the relation of the various celestial bodies to the sun, in addition, correcting the original idea of how planets orbit according to Copernicus. Kepler concluded that instead of spherical orbit, it actually moves in orbits that are ellipses. Through the development of these laws, he not only gave more support to the heliocentric model as proposed by Copernicus, but also refined it, given that it was somewhat lacking in certain areas of explanation. Kepler, also through his works, provided as well the groundwork for another brilliant scientist, who would come to piece together all the theorems and discoveries of the ones thus far. With the contributions of Copernicus and Kepler, it became difficult to refute their claim on the heliocentric model. With the innovation of another scientist, it became impossible at that point to argue for the geocentric model, among other conjectures that supported it. The name of the man who, after only 1 month of becoming aware of the existence of the telescope, built his own and in the same year improved upon its design until it was capable of making telescoping observations of celestial objects, was Galileo Galilei. Galileo was an Italian astronomer, physicist, engineer, philosopher, and mathematician. He is famous for many contributions in a variety of fields, but his development of the telescope, in our particular context, was instrumental in the defense of the heliocentric model. It is important to note as well the integrity with which Galileo defended the heliocentricity. He at times voiced his disagreement of the geocentric system in his writings, and also attempted to assert on the grounds of certain biblical passages of the actuality of the heliocentric model. This caused his summoning on the grounds of an investigation of vehemently suspect of heresy, in which he continued to defend his stance on the heliocentric model, right up until he was forced down on his knees to deny its validity on the physical plane, to which he was unable to object. Otherwise, he would have been probably subject to the torture and eventual killing of a heretic. Nevertheless, his dedication towards science, not only in astronomy, but in physics as well, was admirable and deserving of great respect. Unfortunately for Galileo and ourselves, the story did not end there, and the scientist that would come about to bring about great change was in the same year that Galileo passed away. Through the contributions, discoveries, observations made, data collected and processed, the scientists came to a conclusion of the nature of forces surrounding our everyday lives, as well as that of our ever-expanding universe. The tale of this quite famous physicist often begins with the mentioning of one serendipitous apple, the falling of said apple, and the question, why should that apple always descend perpendicularly to the ground? Newton reportedly thought to himself, or so the story went. To cut to the chase, Newton began his research into the force that brought this apple down from the tree, as well as the interactions of all the kinds of forces on the motion of objects, and discovered their undeniable presence on Earth and beyond, and by doing so, proved the authenticity and validity of the works of Galileo and Kepler, which also validates some of the work done by Copernicus in extension. Galileo, with the observations he had made regarding the nature of motion and forces present on Earth, Newton's law of universal gravitation, in the field of medicine, another man was about to stir a storm of controversy and scorn as his discoveries on the physiology of the human body proved to go against the millennia-old teachings of Galen. The name of this man is William Harvey, an English physician who made seminal contributions in anatomy and physiology. By dissecting both living and dead animals, Harvey became convinced that the ancient Greek anatomist Galen's ideas about blood movement must be wrong. Particularly, the ideas that blood was formed in the liver and absorbed by the body, and that blood flowed through the septum, or dividing wall, of the heart. To summarize, the scientific revolution was a period in which many scientific advances occurred. This marked the beginning of modern science as we now know it, and it is all thanks to these individuals who had willingly gone so far from the popular public opinion that they uncovered the true values and workings of their environment and beyond. The lesson apt to be learned from these people is that, in pursuit of the truth, it is best that one need not be afraid of being different, to be embarrassingly singular in belief or opinion, because it is oftentimes the unexpected and rarely considered, due to biased judgment as shown by history, that holds the greatest possibility of being true.